sort, quick sort, and so on. Okay, so we are going to take the list of elements and we are dividing the list of elements depending on the condition. So quick sort and merge sort applies the divide and conquer strategy. Okay, so how we are going to apply this divide and conquer strategy to the quick sort algorithm? So quicksort is a divide and conquer algorithm. So we are going to divide the list of elements based on the pivot element. So what we are going to do in this is we are going to select a pivot element from the array and we are doing partitioning the other elements into two subarrays. So according to whether they are less than or greater than the pivot element. So how we are dividing the list of elements means, so we are selecting a pivot element and we are going to place the pivot element in such a way that all the elements of the left side are to be less than the pivot element and the right side are to be greater than the pivot element. Okay, so in this, how the divide and conquer strategy follows for the elements existing in the array A, P, 2, R. Okay. So here we are going to consider a list of elements existing from A, P to R. So we are going to divide the list A, P to R in such a way that A, P to Q minus 1 as one array and A, Q plus 1 to A of R in another array by considering A of Q as a pivot element. So you have to arrange the elements such that all the less than elements are on the left array, left subarray, and all the elements which are greater than the pivot are to be considered as a right half subarray. So that means we are dividing the element based on the pivot element. Okay, and then we are considering this left half subarray. Again, we are going to solve this by considering one pivot element in the given list of elements, and we are going to recursively solve the approach such that we are to arrange all the elements in the ascending order. So what we are going to do in conquer, sort the two subarrays. So this is one subarray and this is the second subarray. You have to sort these two subarrays by recursive calls to quicksort. So again we are going to apply the same pattern of the quicksort to solve the two different subarrays. Okay. And next, the last part is combine. Here we are not combining anything. So whatever the list of things are there, we are going to represent in the same manner and we are doing the approach for both left half subarray and right half subarray. So finally we are getting a sorted list of array. So we are not combining any of this. So we are not using this step in this quick sort. So combine is one of the component that is used whenever it is necessary. The most entire part we are doing here is dividing the elements and conquer the elements. Conquer is nothing but solve. So we can solve the list of elements either recursively or non-recursively. So we have two types of approaches. So we can solve recursively or non-recursively. Okay, that comes under conquer. So divide means we are going to divide the given list into two halves. So in binary search, we are dividing it based on the mid value. In defective, we are dividing the square matrix into equal size of the matrices until 2 by 2. So that type of division we are doing each and every case. In the same case, we are dividing the list of elements based on the pivot element. So for this, we are considering three steps how we are going to approach or how we are going to apply the quicksort algorithm. Okay, so this is a partition of algorithm. So here this is going to be verified with the help of three conditions. Okay, what are the three conditions? We are going to consider if A of I less than the pivot element, you can increment the value of I. If A of j greater than pivot element, then you can decrement the value of j. So here I and j acts as pointers for the index in the array. Okay, so we are going to consider two pointers and we are going to verify A of I element with the pivot element, A of j element with the pivot element. If A of I less than the pivot element, then you have to increment the value of I. If A of j greater than pivot element, you have to decrement the value of j. So 1 is, so that means, so when we are moving towards right, we have to apply increment operation. When we are moving towards left, you have to apply the decrement operation. So we are pointing I pointer here and we are pointing j pointer here. And we are choosing always the first element as the pivot element. So we are comparing the pivot element with A of I value and A of j value. So if the conditions are true, we are going to increment the value. The conditions are false. So what is the condition here? If I is less than j, if I is less than j, then we have to swap A of I with A of j. If the condition fails, then what you have to do? You have to swap the, that means what is the condition? If j value is greater than, if I is less than j, we are going to swap the element. So whenever I and j crosses each other, then we can apply swap pivot element with the A of j element. So all of you please note down these 3 points. You have to apply these 3 points to the list of array to sort the elements using quick sort. So always you have to choose the pivot element in the given list of element, and I am choosing the first element as the pivot element. I am comparing the pivot element with the
Ma'am,
yes ma.
you are presenting only first slide, ma'am, from classing.
No ma.
You're not visible. First slide only, ma'am, from starting of the class itself.
All of you, are you getting the same page?
Yes, ma'am.
Yes, ma'am.
Now is it changing?
No,
No,
ma'am.
ma'am.
Now is it changing? Change అవుతుందా?
No, ma'am.
No, ma'am.
What you are going to see here?
First slide, ma'am.
Quick
Sort.
sort, ma'am.
Yes. Now
It's changing, ma'am.
change అవుతుందమ్మా?
Yes, ma'am.
Okay. You have to say initial itself. Okay. Okay, no problem. So all of you once again please listen. I am saying the conditions regarding the quicksort algorithm. So in quicksort we are applying divide and conquer algorithm. So here we are not using the combine operation. So here we are not using the combine operation because all the elements are sorted when we are applying conquer itself. So conquer is nothing but we are going to solve the problem either recursively or non-recursive approach. So binary search we have already seen with non-recursive approach as well as recursive approach. Okay, so in this quick sort we are going to see the recursive quick sort calls for the sorted list of arrays. So here we are dividing the list A P2R elements to A P2Q minus 1 is one subarray and A Q plus 1 to A of R is another subarray. So this is second subarray and this is the first subarray, and we are defining this A of Q as the pivot element. So we are swapping in such a way that the pivot elements comes in the middle position such that all the elements less than the pivot element are on the left side. The greater than elements are all on the right side of the given list. Okay. Again, you have to take the first subarray and we are going to apply the quicksort technique. So that means we are recursively applying the quicksort approach to the sub arrays which are divided based on the element. So while defining these, we are getting the sorted array at the conquer itself. So no need of combine statement. Okay, all the elements are going to be sorted in place. while we are applying this one. So divide and conquer is sufficient, no need of combine. Okay, how we are going to choose the pivot element? So always we are going to choose the first element as the pivot element, and we have to move the pivot element to the middle position to break the given list into two halves. Okay, so I am showing the conditions. So are you seeing the conditions now? Are you able to see the conditions?
Yes, ma'am.
Okay, so you have to write down these three conditions. Based on three conditions, we are going to apply to solve the given list of elements in the sorted array. So here we are using two pointers I and J. Okay, so I places here and J places here, and we are choosing the first element as the pivot element. You are going to compare the pivot element with the A of I element and the pivot element with the A of J element. If A of I is less than pivot, what we have to do? You have to increment the value of I. So suppose I will give the example. So if A of I, we are comparing the pivot element with A of I. So here if we are going to check A of I is less than pivot, then we can increment the value of I. Okay, until the condition becomes false, you have to increment the value of I. Okay, so if it is false, we will move to the J pointer and we are checking the condition. What is the condition to check? If A of J is greater than pivot. So if it is greater, what you have to do? You have to replace in the same position, because all the elements of the pivot which are greater that to be placed on the right subarray, less than are to be placed in the left subarray. So if the conditions are true, we are placing the value of the given list in the same place. So we are not changing the values. If the condition becomes false and if I value is less than J, then we can swap A of I with A of J. So these are the conditions you have to follow. Whenever here I value is here, J value is here. If I comes here and J comes here, what is the value of J? J becomes J is less than I. So whenever swapping of I and J occurs, then we can swap the pivot element with the A of J element. This is A of J. You have to swap the pivot element with the A of J element. Okay, is it clear? So you have to apply these conditions to the list of elements. The same we are going to place in the algorithm also. So this stands for partition algorithm, and we are going to apply three representations in the algorithm. One is partition algorithm, one is quicksort algorithm, and one is swap. Okay, so we are using three functions in the quicksort algorithm. Now I am showing the three functions. All of you see. The first one is partition algorithm. So here what we are doing here, we are incrementing the I value. What is the condition? V is considered as the pivot element until the condition becomes repeat until. So you have to repeat until the condition becomes true. So on the if A of I is less than pivot, then you have to increment the value of I. Similarly, if A of J is greater than pivot, then we can, so less than or equal to, greater than or equal to. So we can represent J minus minus. So we are writing the statement as J equal to J minus 1. If I less than J, what we are doing? We are swapping the elements of A of I and A of J. Is it clear? This all steps are included in the partition algorithm. So until this condition becomes, you have to swap A of I with A of J. So interchange is nothing but swap function. What we are doing in swap function, all of you know about swap function. We are going to choose an initial value, temporary value. So we are storing T equal to A of I equal to A of J. So that means just we are swapping the positions of A of I and A of J. We are swapping the positions of A of I and A of J. So here which includes swap function and partition. But where we are applying this partition is included in the quicksort algorithm. So actually what is the algorithm we are going to do here? Quicksort. Algorithm quicksort. So we have to arrange the elements from P to Q in the sorted order. Okay, so what we are going to do? You are partitioning the elements. Whenever you see partition, it moves to the next function, partition function, and then we are calling quicksort. Why we are calling this quicksort? So we are dividing the elements from A to Q minus 1, Q plus 1 to J. So this is left subarray, this is right subarray. So we have to apply quicksort to the left subarray and we have to apply quicksort to the right subarray in such a way that you have to define the values. So we are calling recursive function recursively to apply the same for the left subarray which is divided and right subarray which is divided. So you have to call this algorithm recursively until all the elements are obtained in a sorted order. So we are using three functions. One is quicksort function. In quicksort function, we are calling the partition function. In partition function, we are calling the swapping function. So in this way, we are going to define the quicksort algorithm. Now we have to apply the same for the list of elements to sort the elements. Is it clear, ma? Quicksort, partition, and interchange. So what this partition includes? These are the three steps the partition includes. If A of I less than pivot, we can write less than or equal to. Then we can increment the value of I plus plus. If A of J greater than pivot, you have to decrement the value of J minus minus. If I is less than J, then swap A of I with A of J. Otherwise, if whenever J value is J less than I, then we can swap the pivot element with A of J value. All of you, please note down these three conditions. Then we will apply the same for the problem. No need to write the algorithm, but you have to practice the algorithm. You have to write the algorithm in exam. I will share the algorithm. You can write later. Okay. Now no need to write the algorithm. So, but algorithm involves three functions. What are the three functions? One is quicksort function to represent the algorithm. In quicksort, we are calling the partition function. The partition includes the pivot element to arrange the elements which are less than the pivot on the left subarray and greater than element on the right subarray. Again, we are calling the quicksort function to the left subarray and right subarray. Okay. So in this way, we are going to define the quicksort algorithm. Shall I move to the problem, ma? Are you ready with the conditions? All of you once define the conditions. Any three of you? I want to know the conditions. What to be considered? What are the three functions we are using in the quicksort now? What are the three functions we are using in the quicksort? What are the three functions we are using in the quicksort algorithm? The first function is quicksort algorithm. In quicksort, we are calling the partition function. In partition function, we are calling the swapping function. Swap is nothing but interchange. Interchange means moving the place of one position to another position. We can replace A with B and B with A. Does anybody tell me? Yes, partition, quicksort, partition, okay, and interchange or swap. So in quicksort, we are calling partition, yes, swap, very good. So can we apply the problem now? Bhavya, what are the conditions you have to consider now? 75, Bhavya. 52. Farheen?
Yes, ma'am.
Yes, I want to hear your voice. Please say the conditions. We are
If A of I less than pivot element, then we have to increment I, ma'am.
Yes. What is the next condition?
A of J greater than pivot element, we have to increment J, ma'am.
You have to decrement J.
increment J, ma'am.
Okay. Then what is the next condition? Yes, Bhavya. Okay. If I less than J, then you have to swap A
Swap.
of I with A of J. Otherwise, you have to swap pivot element with A of J. Okay. All of you note down the problem. Consider the list and sort the elements using quicksort. Consider the list and sort the elements using quicksort. Are you able to see the elements, ma'am?
Yes, ma'am.
Okay. Please note down the elements. $26, 5, write down 26, 5, 37, 1, 61, 11, 59, 15, 48, 19. $26, second element 5. All of you write down. You have to solve along with me. Examples are also important while analyzing the algorithms also. You have to learn the algorithm, you have to learn the strategy, you have to apply the algorithm and then analyze the complexity. These 4 are included for each and every application. All of you remember carefully what we have to do. First, you have to apply the divide and conquer strategy. How divide and conquer applies to the given application. And then you have to solve the problem. You have to learn the algorithm and then you have to analyze the complexity. These 4 are to be defined for each and every application in every technique. Okay, in every technique. Okay, so can anybody say the elements, ma'am? What is the first element? 26.
5,
5. Make it fast.
37,
37.
1,
1.
61,
61.
11,
11.
59,
59.
15,
15.
48,
28.
48, ma'am.
Okay, 48.
19.
19.
Yes, ma'am.
Okay. All of you see carefully. So first I want to consider this as a pivot element. Okay. And I am using 2 pointers. One is I value and one is J pointer. So you have to apply at the same point I and J. Okay. So here I am assigning the values of index values for the given list of elements 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this I value takes the value of 2, J value takes the value of 10. Okay, so the first condition we are going to check is what are the conditions, ma'am? Here I am writing the conditions. If A of I less than or equal to pivot element, you have to increment the value of I. If A of J greater than or equal to pivot element, you have to decrement the value of J. If I less than J, swap A of I with A of J. Swap A of I with A of J. Else, if this condition false means J becomes less than I, then you have to swap pivot element with the A of J. So you have to remember these 4 conditions and you have to apply the same here. So here I am comparing the value of A. What is A of I? Is 5. So 5 is less than 26. So 5 is less than or equal to 26. Condition true. If the condition true, what we have to do? You have to increment the value of I. So I becomes 3. Okay, then I want to check the value of A of 3. A of 3 is 37. 37 less than or equal to 26. Condition becomes false. When the condition becomes false, I will move to the J pointer. J value is 10. Now I want to compare A of J value with the pivot element. What is the condition here? 19 greater than or equal to 26. Is 19 greater than or equal to 26? No, this becomes false. When both the condition becomes false, you have to check the value of I and J. Is I less than J? What is the value of I? 3. 3 is less than 10. Condition true. When the condition is true, what we have to do? Swap A of I with A of J. You have to swap A of 3 with A of 10. What is A of 3? So swap A of 3 value is 37. A of 10 value is 19. So you have to interchange the positions of 19 and 37. Now what is the list obtained? So 26, which is considered as a pivot element, I is 5. 37 is to be replaced with 19. Interchange the positions of 19 and 37. 1, 61, 11, 59, 15, 48, and the last value we have to write is 37. Okay, now where is the I value? I value is third position. So I equal to 3 and J equal to 10. There is no change in the J value and I value is incremented to 3. Okay, now you have to repeat the process. So you have to check the value of A of 3. What is A of 3? All of you complete till this. Repeat the process. So what is the value here? You have to check for the value of 19. 19 less than or equal to 26. Condition true. Then increment the value of I. I becomes 4. So then check the value of 1 less than or equal to 26. Condition true. Then I is incremented to 5. Here I want to check the value 61 less than or equal to 26. Condition becomes false. I stops at this point. Okay. Then I want to verify J value. 37 greater than or equal to 26. Condition true. Then decrement the value of J. J becomes 9. Then I compare 48 with 26. Condition true. Again I can decrement the value of J. J becomes 8. 15 greater than or equal to 26. Condition becomes false. So here I value is at 5th position, J value is at 8th position. Then what I have to do? I have to swap 61 with 15. 61 with 15. Now say the list of elements now. Shall I move to the next slide? Are you able to write now? Or shall I go slow? Are you able to solve? Is it clear? Avinash, is it clear? Bhavya? Farheen?
Ma'am. Yes, ma'am.
Yes. Now can you say the list of elements now? 26, 5, 19, 1. I have to swap the element 61 with 15. Then 11, 59, 61, 48 and 36. This is the new list obtained. So this is the pivot element. Until the pivot element is swapped to the middle, you have to do the elements. So you are considering the I value is at 5th position and J value is at 8th position. Again, you have to repeat the process. What is the process? So you have to compare 15 less than or equal to 26. Condition true. I is incremented to sixth value. So 11 less than or equal to 26. Condition true. And I is incremented to 7. 59 less than or equal to 26. Condition becomes false. Now, when the condition becomes false, you have to check for the J pointer. So J equal to 8, 61 greater than or equal to 26. Condition true. Then J value is decremented and J position comes to 7. So here 59 greater than or equal to 26, condition true. Again J value comes to 6th position. So J value, what is the 6th value? 11 greater than or equal to 26. Condition becomes false. But what is the value of J here? J is 6 and I is 7. When J is 6 and I is 7, what do you have to do? What do you have to do, ma? You have to swap. So here what happens? I and J crosses each other. So J value becomes less and I value becomes more. When this happens, you have to swap the pivot element with the A of J value. What is A of J here? J is stopped at 11. So you have to swap 11 with the pivot element is 26 and A of J value is 11. So now what is the list obtained, ma? Now we will get 11, 5, 19, 1, 15, 26, 59, 61, 48 and 37. So the pivot element is going to divide the list of elements into subarray which are all less than 26. 11 is less than 26, 5 is less than 26, 19, 1, 50. Each and every element less than 26 are placed into the left subarray. Okay, and similarly the right, if you observe 59 greater than 61, 48, 37, each and every element greater than the pivot element are placed on the right subarray. Is it clear now? So in this way, we have to divide the list of elements based on the pivot element. Okay. Now what you have to do? You have to take the left subarray and you have to apply quick sort process again. So quick sort of P comma A plus 1. So until this position. So then I minus 1, here J plus I plus 1 to last element. So these are the two recursive calls we are going to apply in the quick sort algorithm after partition. Partition means pivot element comes in the middle and we are dividing into two subarrays. Again, we are going to call quick sort algorithm to this part and quick sort algorithm to this part. Okay. Is it clear? Shall you continue the problem? Or again, I have to solve the left subarray and right subarray. So now what is the list of elements obtained? 11, 5, 11, 5, 19, 1 and 50. 26, 59, 61, 48, 37. So this pivot element remains same and we are considering this part and this is considered as the pivot element. Again, we are assigning I value at this position and J value for this array at this position. So 1, 2, 3, 4, 5. Again, you are going to repeat the process until 11 is to be placed in the middle. And similarly, you are going to consider this as a pivot element, I value at this position and J value at this position. Okay, repeat the process and you have to swap the elements. Shall we do this? So I equal to 2 and J equal to 5. So 5 less than or equal to 11, condition true. I is moved to 3. 19 less than or equal to 11, condition is false. Here 15 greater than or equal to 11, condition true. Here 1 greater than or equal to 11, condition false. So here I value is false, J value is false. I value is 3 and J value is 4. So you have to swap A of 3 element with A of 4 element. So you have to swap 19 with 1. So after swap, what you will get? 11, 5, 1, 19 and 50. So here we are going to have I value as 3 and j value as 4. When you compare this one is less than or equal to 11, condition true, I is incremented to 4 and j is decremented to 3. So here I and j swaps each other. So you can swap pivot element with the A of j element. A of j is 11. So you are going to swap 11 with 1. Then you are going to obtain the list as 11, 1, 1, 5, 11, 19 and 50. So 11 is the pivot element. All the elements less than pivot element are placed in the left subarray. Greater than elements are placed in the right subarray. Okay, this is the left subarray we have repeated, and we have to repeat the process 26 in all the cases, 26, and then you are going to apply the right subarray. So I is placed at 6, 7, 8, 9, 10. I is placed at 8th position, j is placed at 10th position. Okay, so compare 61 less than or equal to 59, condition false. 37 greater than or equal to 59, condition false. So if both are false, I is less than j, you have to swap 61 with 37. So when you swap 61 with 37, what is obtained? 59, 37, 48 and 61. So I value is at this position, j value is at this position, 8 and 10. So I 37 is less than or equal to 59, condition true, is incremented to 48 less than or equal to 59, 48 less than or equal to 50, condition true, and it moves to j, 61 less than or equal to 59, condition becomes false. So I stops at 10, I value stops at 10. You are going to compare 61 greater than or equal to 59, 48 greater than or equal to 59. Condition false. So j and I swaps each other. You can swap the pivot element with the element. So then you will obtain 48, 37, 59 and 61. So this is the list you are going to obtain finally. Okay, so here this is one pivot element in the first case, this is another pivot element in the second case, and 59 is one more pivot element in the next one. So here, 1, 5, 11. I'm sorry, 1, 5, 11. 1, 5, 11. So 1, 5, already these two elements are in the sorted order. Here we have only two elements. You can swap the two elements 15 and 19 by using swap. Here also 48 and 37 by comparing you can swap the elements. So all the elements are obtained in the sorted order. So this is the representation of quick sort algorithm. So you can slowly apply the algorithm recursively. So quick sort algorithm needs three functions. One is quick sort function to arrange all the elements in the ascending order, and this involves partition algorithm. So partition, we are considering a pivot element. So see here, first we are calling the quick sort algorithm. Are you able to see the quick sort algorithm now? Again, I am repeating the same. So quick sort algorithm involves partition algorithm. So in partition, we are dividing the two elements based on the pivot element. Whenever partition comes, we are moving to the partition algorithm. Here we are assuming the first element as the pivot element. So V, here V acts as a pivot element. So V equal to A of M, we are storing the pivot element, and I equal to M and J equal to P. So we have to repeat the process until I greater than or equal to J. So whenever I greater than or equal to j, we can swap the element, swap the pivot element with the A of j element. So for this representation, repeat until we are using these three conditions. If A of I less than or equal to pivot, you can write equal to also. If A of I less than or equal to pivot, then increment the value of I. If A of j greater than pivot, then decrement the value of j. If I less than j, then swap A of I with A of j. Otherwise, you have to swap the pivot element with A of j. Okay. Is it clear? All of you slowly solve the problem and arrange all the elements in the ascending order. Is it clear? Okay, ma'am? All of you having any doubts in solving Quicksort algorithm and learn the algorithm? Tomorrow we will analyze the time complexity of the Quicksort algorithm. Oh. Okay, tomorrow we will see with another example. No need to worry. A6. Okay, Shahid, I will explain tomorrow with another example and then we will learn the time complexity. Okay, so we will solve the problem from the previous papers. Okay, no need to worry. Tomorrow I will explain once again the example with different list of elements. So, but please follow the three conditions carefully. Is it clear now, all of you? So please, all of you, once again try the problem. Okay, I have already shared the question papers in the Moodle also. You can take the list of elements from the question papers and you can solve the problem once again. Okay. Tomorrow we will see the time complexity of Quicksort algorithm in best case and worst case. You all know that in best and average case, the time complexity is order of log n. In worst case, order of n square. How we are defining the worst case time complexity and how we are defining the best case and average case time complexity. What are the recurrence relations that supports the Quicksort algorithm? Is it clear, all of you? Are you ready to explain the process involved in the Quicksort algorithm? What are the conditions? What are the functions? Is it clear now, all of you? Tomorrow I will start with the same example and then we will analyze the time complexity. Okay. Is it clear? Okay, all of you. Thank you, one and all.